Welcome, everybody, to the February 6th, 2025 CADXA meeting. I'm John, N7NWL. A couple of things we're going to go over tonight. Not a whole lot of in-depth things. We don't have to vote on anything that I'm aware of. But for starters, I want to just present very briefly this is the current new slate of officers. We went into this year with a vacancy in the secretary position, and the board filled that with Jim, KC1BB, so he's vice president. Treasurer is Mike, N7. Secretary? It says Secretary Bob Hanson, Vice President Jim, KC1BB. See, he always reads stuff like that, and I always do this, so don't panic. It's a normal thing. Mike's the treasurer. He couldn't be here tonight. Secretary is Bob, NA7RH. Director at large is Steve, N7TX. Other director at large is Brian, wherever Brian got to. He's back in the back. Past president is Bill Poole. So moving on from there, let's see if this works. It will in a minute. The first thing we're going to do tonight is member introductions. We got 25 of us here. So I'm John, N7NWL. If you would kick it off, Andy.
Sure. I'm Andy, NY7N.
Bob, K7BHM, and we want to welcome Andy. This is his first meeting tonight.
Gary, K9SG.
Steve, K7SP.
Eric, KC7ES.
Dave, N7RK.
Bob, NA7RH.
Ron, WA0KDS.
Yeah, Mike, K7ING.
Richard, N7, and a new member.
Dan, KC7MSU, new member.
Jim, KC1BB.
Dan, K9DR.
Mike, KC7V.
Brian, W7JET.
Joe, WHJH.
Lee, KY7M.
Warren, K7WX.
Norm, N9AV.
Walt, NJHG.
Phil, N7PWZ, new member.
Gary, K8BN.
Steve, N7TX.
And Virgil, K7VZ.
Zoom people.
We do have a couple of new members. At the Hamfest on December 7th, we had our first booth set up there for CADXA. Virgil was there, I was there, and our vice president now, Jim, KC1BB, was there. What? Well, Zoom introductions. We've got Rick, W1HZ. I can't see him. Virgil's here, I'm here. Ray, N6VR is here. Warren, KC0GU is here. And Doug, K9RZ is on Zoom. So we got some fairly good Zoom participation. Tim is here, K3LR, and he's down there. So that pretty much takes care of the introductions and things like that. Our meeting tonight is going to be on station grounding and bonding. Tim Duffy, K3LR, who I'm pretty sure most of us are familiar with at some level, is going to be our presenter. And I like to do a brief introduction, but it's like virtually impossible to adequately introduce Tim, K3LR, for a lot of reasons. He's been an amateur radio operator, station owner, developer, et cetera, for decades. You can all read the rest of this stuff or listen to me. But you can check out his qrz.com page. You can go to k3lr.com for a glimpse into some of his contributions into our hobby. And I want to take a real quick minute here and thank Tim, because DX Engineering generously supports the CADXA with door prize contributions. They've done that for many of our events throughout a number of years. And I just want to thank Tim and DX Engineering for their ongoing support. So thank you, Tim. I appreciate it. And we are now ready for the presentation. So Tim has it.
Okay. Thanks very much. And I appreciate the introduction, and we'll get right into it here with my slide deck. Okay, and I hope you see my slides.
Looks good.
Great. All right. Let's talk about grounding and bonding for HF stations. And this is a collaborative presentation that I've done with Ward N0AX, who wrote the book Grounding and Bonding for the Radio Amateur. And so really what I want to make sure that you get out of this presentation is the difference between grounding and bonding. And I'm going to talk about HF contest stations, but every one of these principles also translates to DX stations, or stations that you're designing to work DX, or if you're getting on 40 and 80 meters for rag chewing. There's a very system approach here that satisfies all the requirements for different kinds of stations. All of this material came from the grounding and bonding for the radio amateur, as well as the ARRL handbook, some of the NEC material, and WHAI site. There's lots of great reference material on the internet, so it's not like you have to go out and buy anything. But if you are going to buy something where you want to understand grounding and bonding better, the N0AX book is a must-have. It is in its second edition. Thousands sold, but it covers all your AC wiring, lightning protection. The peer reviews have been extensive, so it's really solid stuff. And there's lots of examples so that you can figure out what is going to work best for your station. And realizing that ground has different meanings, and it's not just a place that you can throw energy that you don't want. It's not some magic cesspool, but it is an earth connection. And it also refers to some of the things that we do with bonding. And so when you say you're grounding the chassis to a ground, that may really refer to bonding. So remember that earth is not just a place you can put things that you don't want, like RF that you don't want. And there's really no such thing as RF ground. And we're going to talk about single point bonding connections. And each set of these requirements really has to be approached differently, but we're going to really focus on bonding. And especially in Arizona, grounding, getting good connections to the earth are really important from lightning. That's really where that's done. The rest of the hard work is done in the bonding area. And we want to make sure that everything in your shack and in your house and outside goes up and down together. So there is no difference in voltage potential. That's really what we want to make sure that we do, because if you have voltage differences, especially those caused by lightning strikes, you will have things blow up. It's that simple. Bonding is not hard and it's not expensive, but you do have to know what you're doing. And the great thing about bonding your equipment together and bonding your equipment together with your AC distribution panel is all this stuff works in your favor for AC safety, lightning protection, and good RF management. But for it to work, it has to have low impedance, and the physical length of the conductors has to be as short as possible. In the cases of lightning, these conductors have to be heavy enough to carry the expected current, and also if they're outside, they have to be able to survive the environment. In the station, I like to use tin copper braid. Even better is strap, 1.5 inch or 2 inch wide strap, heavy wire. Remember that we don't want to use braid from old coax because the unprotected copper will deteriorate very fast. And even using tin copper braid outside is a no-no because it will also deteriorate very fast. AC safety ground, that's the third wire ground or green wire ground. Very important when it comes to AC safety. We want to make sure that we do keep our ground connections very low resistance. That means that they've got to be clean. I like to use CAD weld. That's the best way to keep low resistance connections going. And we do want to make sure on AC safety ground that we have that common point for fault currents, and also the connections to earth stabilizes our AC power systems because they work against ground as well when it comes to the pole. And your utility transformer, which is either down on the ground or up on a pole, has got 3 wires coming out of it. One of those wires, the center tap, has its own connection to a ground stake. And then there's 240 volts that comes into your panel, and there is a neutral bus and a ground bus. And that main bonding jumper is only in the main panel. You may not, absolutely never, bond the neutral and ground together in sub panels. So that's only done at the main panel. And then the main panel also has its own grounding electrode very close to the panel itself, and that's connected to the ground bus. Making sure that you know what you're doing. If you don't do this every day for a living, like you're a certified electrician, then you either need to get some books, get online, or better yet, hire a professional electrician that is bonded and understands the work completely, knows how to do inspections, and somebody that your insurance company will look at as being a professional that can write that everything is done properly. When it comes to lightning protection, we want to help lightning make good decisions. So we want to have good direct pass to the earth, and the pass should be outside of your residence. And we don't want to make it easy for lightning to go through your station on the way to ground. Last night, K1LT blew up his L-Craft K4 because there was lightning due to a weather front that came through here that did an ice storm, and it blew up his antenna ports in his K4 and his Ethernet connections because he did not properly bond things together. And the single point ground panel, very important. Everything must be connected to that single point ground panel, including some of your lightning protection. That is, in the case, polyphasers, AC lightning protection, as well as MOVs and gas discharge tubes that you can see here for control wires or rotator wires. The single point ground panel, the SPGP, bonds all the grounds of all the entry paths, and they are connected to the perimeter ground that goes around your house. And we want to make sure that we keep our protected and unprotected cables separated. Here are some examples of single point ground panels, and all of this material is inside Ward's book. This is a K4RO on an aluminum sheet, and all the filters and all the switches are mounted on this aluminum sheet. At N0AX, you can see the extensive single point ground panel that everything is mounted on. And you bond all your earth connections together, so you see that the electrical panel and your station ground system are all bonded together. You do not want to do this. Notice that there is no ground rod at the tower. That's bad. notice that there is no connection from the shield of the coax to the tower. Notice that there is no connection from the ground rod that has the shield coming in. There's no connection from that ground rod to the AC service entry ground rod. That's bad. So this will promote lightning problems or static discharges going through your radio. What you want to have is the proper connection to a ground rod at the tower, and then all of the perimeter grounds are connected together. And that will keep lightning outside of your house and not going through your radio equipment. Yeah, with a tower, it's good to have more than one ground rod. It's good to have multiple ground rods. This is exactly how I ground the towers here at K3LR to make sure that there's a very, very low impedance connection to ground. You want to make sure you bond your feed line shields to the tower legs, or you want to have a spark gap if you have series fed vertical antennas. Another example of the single point ground panel. This is at the tower base. Notice the aluminum plate. Notice the connection to the ground rod. Here's the copper cable and gas discharge tubes on all of the control wires. Another example here, lightning protection on all of the hard line, and then gas discharge tubes and a connection to the ground. Wanting to make sure that everything that is crossing the boundary must be protected, and then you bond the equipment within the station. Remember, everything in the station is an antenna, and you want to make sure that it is all bonded together. The AC safety grounds are bonded, RF bonding, and again, this is all explained in the book, and it's not hard to do. And then there is a single connection from the single point ground panel to the perimeter ground system. We want to concentrate on bonding. You would keep our connections short and tight and make sure they're clean. This will keep everything at the same voltage. We want to make sure that we give our amplifiers extra attention to bonding. And here is the RF bonding bus. RF bonding bus has separate connections to each component in the station, and then a strap to the single point ground panel. This reduces all the hot spots, buzz, and hum. Bonding is the real deal. We want to minimize our loop areas, use short or coiled cables and shielded cables too. And here is the RF ground plane. I have RF ground planes here at K3LR. They work very, very well. They're underneath all the radios and all the amplifiers. They connect to the RF bonding system, which connects to the station ground system. But you can see the connection from the radio onto the RF bond. Again, we've got an RF bonding, RF ground plane on the back. Everything is connected to it. And remember that you have this single solid ground system satisfies all the requirements for AC safety, RF management, lightning protection. Keep all the bonding together, and then all currents flow on all wires. And that also makes sure that you don't have any voltage potential differential. There are additional resources online from the International Association of Electrical Inspectors. Mike Holt has got a really good website, as well as Motorola's R56, which is a 400-page document. That's available for free online. And the ARRL has tons of great information on electrical safety, grounding, and lightning protection as well. Remember that you want to have this RF ground plane. It's very, very important to keep everything safe and at the same voltage potential. Here you can see the RF ground planes at K3LR before the radios are put in place. And then there's a connection to the RF bonding bus. From the RF bonding bus, we go to the ground system. Here's the ground system, number 2 wire solid. And here we have the connection to the radio, connection to the amplifier, connection to the antenna switch. So this is the RF bonding bus. Here's the connection to the RF ground plane. Then the RF ground plane connects to the radio. And we're keeping our cables together using shielded cables. Radio goes on top of the RF ground plane. Here's 2 radios, 2 RF ground planes. And again, the RF bonding bus using good high conductivity brass hardware and external tooth lock washers, connections with tin copper braid to the back of the ICOM radio, back of the amplifier to the RF ground plane, from the RF ground plane to the RF bonding bus. More connections from amplifiers to the RF ground plane. And so that is my presentation, and I am available for any questions you might have.
Thank you, Tim. I appreciate it. Any questions from the audience?
Yes, this is Ray in 6VR.
Hi, Ray.
Tim. I have 4 towers, the Sky Needle at 90 feet. Everything is grounded, like you say, radio's going out, and grounded every with the CADWell. Our soil here is really dry, and we can't get ground rods more down, sometimes more than 6 feet. And I've used number 8 to connect all these ground rods with a CADWell or something like that, or even like 6s or 2 wire. My concern is that our soil is acidic, and limestone calcium builds up on all these connections, even the ground rods. I've got a friend who's done ground rods too, and he puts a water source and pours water on it. And I'm wondering how effective these ground rods are over time, because I think they build up, they're not conductive to the soil anymore.
Right. That's a great question, and I don't have a good answer for you, Ray. I don't know what the most efficient way to try and keep those ground rods active. But I would suggest that you go to some of those online resources and take a look. Obviously, the cell phone carriers out there in Arizona, they know what they're doing because they have to have their stuff survive lightning and lightning charges and static electricity, and they have the exact same problems that you would have. And so I would hope that maybe somebody in the amateur radio community might have a link with Verizon, AT&T, or T-Mobile. I used to work for AT&T. There's some very, very smart engineers there. And Ray, I would pose that to Arizona literate engineers out there.
Okay. I'll think about that and see how I can get to them. Thank you.
Any other questions?
Yeah, we got one coming, Tim.
Yeah. Can you hear me okay?
Yes.
Okay. This is Gary, K9SG. We have a station that 8 of us use for remote, and we have stations scattered 10, 12 feet away from the single common ground. And do you take a big wire or bus or something and have individual little areas where you ground your radio to when they're spread out like that? Because some of them are probably 15, 18 feet away from where we have a common bus ground for something that's in a rack. And so I have a little trouble understanding the common point ground. So do you just connect something with wiring and then a common point ground?
Yeah, in that case, what I do here, because I have the same issue where I've got stations, radio equipment and amplifiers spread out, Each one of the radio amplifier combinations goes to a single copper connection point, and then that connection point, I use 2-inch strap to connect between those connection points.
Okay.
More questions? Any more questions from the folks on Zoom? Hello,
Just
Mr.
say-
Dave. Do you have any questions on grounding or bonding or stuff? Okay, good.
This
Yes,
thing,
sir.
Ray, N6VR. Yeah, Preston N6SS lives about 20 miles from me. He has 150 foot of road 55. He's done all this insulation, all the grounding that should be done. One of his errors he did during the lightning storm, he disconnected all kinds of stuff, which is another way to go. But he forgot his 6-meter antenna on the K3 port 2, antenna point 2. He did everything else fine. The lightning came down and blew out the K3 because he forgot to take the antenna 2 port, disconnect it. It's a shame.
Is there a question?
No, I just a point that, you know. you can't
I
think
was
of-
waiting for the question. Okay.
I'm sorry. You can't think of everything. You think you've done everything, but then one little thing that you didn't disconnect the 6-meter
Okay.
from port 2. Okay.
Any more questions from anybody? Comments, thoughts? Okay, Mr. Tim, thank you, sir. I appreciate it. As always, we appreciate DX Engineering's involvement with us. We appreciate your presentations, and thank you, sir.
All right. Well, thank you very much for having me this evening. And to those of you who are DX Engineering customers, thank you for your trust and your business. We try to make sure that we take care of everybody as best as possible. But if you ever have problems, now you know the CEO. So you can email me and I will make sure that we get your problem solved. We do have a warehouse in Sparks, Nevada, which services Arizona very quickly with our shipments. And if you're not a customer of DX Engineering, give us a shot. Give me a try. I think you'll be pleasantly surprised how well it goes. And I, once again, I appreciate it. And Lee, it was great to talk to you on the phone earlier.
Hey, Tim, Sparks is a great place for a grounding supplier.
There you go. All right. I'm going to get off to my next club meeting that starts here at 9 o'clock. So 73, everybody.
73, thanks, Tim. I appreciate it.